Okay, so now we're going to work on part 4. So if we look at our PDF for part 4, what they want you to do is to calculate the alcohol by volume at the final time, which is going to be 200 at different temperatures, ranging from 10 to 20 in steps of 0.25. And finally, they want you to plot the alcohol by volume as a function of the temperature. So what we're seeing is how doing the fermentation at different temperatures is going to affect how much alcohol we produce at the end. So now, if we look at our template, we see that the first thing you have is how to create that temperature vector. And you see that you go from 10 to 20 degrees in steps of 0.25. That's what the 0.25 in the middle is telling you. So now the next thing he does is to create just the variable, create a variable called ABV. Now we're gonna see a for loop. So how this for loop is gonna work is it's gonna start with I being 1. That's what it means, I equals to 1, and then it's gonna do it in steps of 1. So you can also do this, but when you don't add anything, it's gonna do it in steps of 1. So it's gonna say I equals 1, and then it's gonna run, and then it's gonna make I equals 2, and it's gonna run, and so on and so forth until it gets to length t. So for example, in this case, we have that t is from 10 to 20 in steps of 0.25. So the size of t is going to be 41. You're going to have 41 temperatures. From 10 to 20, you're going to have 41 temperatures. So this is going to run 41 times. It's going to run one time, the first time for the first temperature. So the first time is going to be for 10 degrees. Then the second time is going to be for 10.25 degrees, and so on until it gets to the length of t, which is 41, which corresponds to the temperature 20. So if this is not clear, let's just make it here real quick. So for example, if we create that, if we just run that line on our command window, we see that we're creating a variable of size 41. So we have 41 inputs. If we say length of t, then this is going to tell us we have 41 numbers. Now, if we say t of 1, this doesn't mean that our temperature is 1 degrees. It's going to tell us what the first value of that vector is, which in this case is 10. If we say T41, it's going to tell us what the last one is, which is 20. Now, let's say we have a counting variable, in this case I, and we're going to make I equals 5. So if we say T of I, what it's going to tell us is it's going to give us the I number, in this case the 5th number, which in this case is 11. Does that make sense? So we're going to step in 0.25s, but we're going to have a total of 41 temperatures. And what this is going to do is it's going to run through every single temperature one by one. So now the first thing that we need to have in our ODE is our initial conditions. So the initial conditions are the same ones that we had before, so we can just go ahead and copy and paste those initial conditions. Of course, here you have to fill in with the rest. I just have the first 3. So that's the first thing you need. And then what we want is we actually don't have to put this in the loop because these are going to be constant, so we can put it right here. Then what we need to have is our Arrhenius function. So basically what we want to do is we want to calculate, so if we go back to our function, we want to calculate all of these constants for each one of the temperatures. So a lot of mistakes that I've seen, so if we copy and paste this, and then we put it right here. So a lot of errors that I've seen is that you just leave it like this. Well, this is not correct, because if you do this, then t is a vector, and you're going to calculate a vector for each one of these, and we're inside a loop, so we actually want to calculate this individually. So we want one by one, so we just want one set of constants. And then every time you loop through it, you're going to update it with the new value of t, and then with the new set of constants. So we actually want to say t of I. So the first one is going to be, of course, 1. So you're going to first calculate all of these constants for temperature 10. Then when I becomes 2, then you're going to calculate all of these constants for temperature 10.25, and then like that until you get to 41. Now, that's calculating all of your constants. That's the first thing you need to do. Then the second thing is, same as part 3, you need to create that f function. So we can basically just copy most of our part 3 into our part 4. We're just doing the same thing we did for part 3, but for every single one of our temperatures, if that makes sense. So a lot of people are putting ice in here as well, but you don't have to. You don't have to, because every time you run this, these, after you change the temperature, all these constants are going to change and are going to have the value that you want them to have. So you don't have to put ice anywhere besides here. So now we calculate a function, then again you need your OPTODE set. So we're gonna just copy, we're just basically gonna copy this whole thing. So remember that here I didn't write everything. You have to fill in for your ODE, but if you already have your ODE for part 3, you can just copy it for part 4.